Okay, I think I'm live. I think. Let's see here. Wait here a second. Send out some messages. Yep, send that. And that. Okay. Do there. And there. Nope, did not do what I wanted to do. Trying to get all this sorted out there. All right. So this started. So right now I've got a couple of things, different uh, product ideas, whatever, that I've already got sent out being made by PCB houses. But in the meantime, I figured I'd just play around and have some fun. So um, I wanted to design a smart coaster, which I mean it's incredibly stupid, but uh, there's some design challenges that are involved with it, so it might be a fun exercise. What do I mean by smart coaster? Make sure I'm not dropping. Okay. So there's like let me see if I can find a. I'm calling it a smart coaster. It may not technically be like actually smart, but there's, if anybody's seen this show Dream Master, you'll see like on if I can zoom in on this. Oh geez. There is they have this light underneath their bar, which kind of gives all their drinks like this fancy look. I don't want to build an entire countertop like that, but I think it'd be cool to build like a coaster that lights up like that. So if you take your drink glass and you set it on top of it, it lights up basically. What I wanted to be smart about it is, I wanted to be able to turn on and off depending if you put the drink on it or not. So, oh God, my cat's crying. If you can hear that, I apologize. So, don't cry. She wants to go outside, but it's freezing outside. So, anyways, let's get. I've already kind of started laying out some of the schematic. Part of this was like, I've had a few different ideas in my head, and I'm like, I can make it a dumb smart coaster if that makes any sense. Um, where I don't need to put an ESP32 in it, but I have a ton of ESP32 modules lying around, so I figured why not? And at least that way I can control the RGB LEDs. I can, turn them a certain color, if I wanted to, things of that nature. So I've already got some of this laid out. Let me look here and make sure. Okay, got our battery voltage monitor. We got that. I think that's everything. I'm going to. I might have to update my footprints. I don't know. I'm gonna update the schematic if it takes a second here. Annotate. Okay, it definitely does not have everything. All right, so I gotta go through here, and for some reason it's not. All right, well, I don't know how this happened, but like a bunch of my footprints and stuff got screwed up. So we'll go through and manually do it, I guess. Import. Where did I save that to? Expressive footprints. S3 mini. Save. User save. Okay. Down here, find our. Okay, we got that one. So we got our USB. We got a bunch of stuff. Let's see here. Okay. Doesn't have the LDO, which is a problem. Okay. All right. Let's see here. I think I'm gonna need that one's there. Although that's the really tiny one. I don't need to use the super tiny one. Come on, cat. Really? Can't let you outside. I'm sorry. It's not let me. All right. Well, give me a second. I can take care of this cat. I apologize. Let me put it on. All right. Sorry about that. Okay. Where was I? All right. So I'm setting up these. It's 523. I'm gonna set up. I think it's 323. I think. Oh, not that one. Trying to update some of these. There we go. There's a footprint. Footprint. And that one is that one. Geez, which one is it? Might be 523. Update our schematic. I'm going to go back and forth here a little bit. Got that. Got that. Got our LD. Or no, we don't have this one. That user. If I have this one saved in here or not. I do not. Okay, let's see if we can't add it if I can find it. Give me a second here. I'm gonna try and figure out where I saved some of this stuff. Kind of got it scattered to the wind. There. PCB files. Parts. Oops. I think it's this one. user, and then two. Where'd it go? Just saved it. What the heck? I literally just saved it. Import. Okay, it's something or another. Save. Under user. Okay, maybe it was there. Just under a different name when I was expecting. This one. Here we go. Okay. Those. Buttons here. Should be this. Yeah, it's fine. We'll just use those. Okay. Those. Rename our LED here. Means I gotta do all these. Okay. That one. All right. File, save. There's a bunch more stuff. Off. User comments. Okay. Where is missing? Oh, it should be on there. Why is it not on there? Oh, there it is. Okay. All right. Okay. So, I think that's more or less I think that's everything. I think. Got our buttons, got a USB-C. We have a switch. Okay. All right. So, let's see how this looks. Take this and move this out of the way. I guess I can just put it over here. All right. Okay. So, one thing we need to figure out is how big do we want this PCB to be? I'm thinking, let's do it in millimeters. I'm gonna take my glass and just kind of get a rough idea of how big the bottom of this is. 75 millimeters, which works out to 3 inches. Okay, so that's about what I was thinking anyways. So 3 inches. In the meantime, let's kind of straighten some of this stuff out. We don't have to be too confined by our sizes and stuff. Let me look and see. I'm not sure how big I made these. Okay, 0603. All right, that works. They don't need to be tiny because we have a fairly large PCB we can work with here. Okay. So the easiest thing, let's just try and group some of this stuff together. Turn this off. little bit easier to see. Okay. So we've got all those. Let's see here. Now, we can take, let's go edge cuts. So 75 divided by 80, 232. So this should be about 75 millimeters. Or not. 64. Make it a little bigger. This doesn't have to be exact because I'm kind of just making it to whatever I want it to be. Close to 70. Okay. All right, that's good enough. Okay. So this here's our PCB. Essentially, I'm going to make some probably modifications to it a little bit and make, for instance, we'll probably make the USB stick out the end a little bit. So I'm going to 3D print a case for it. We got our RGB LEDs. I'm going to turn off all this stuff because I don't want the silk screen and stuff to show up. Shift it over here in case you can see it. Okay. 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 All right. Let's see here. All right, so we've got 6 RGB LEDs. Let's find the first one. That's number 1. Oh, that one's somewhat close to. I still not decided, like, do I want to put the ESP32 out here? The opposite side of the, we could probably do that. Okay, that's 1. Let's find 2. So I'm finding these RGBs that are in sequence, basically. That's number 3. 4. Like that. 5 and then 6. Okay. So let's see how far apart I need to make these to kind of get somewhat equal spacing here. Make like an octagon. I think that's the right. Oops, not that. Something like that. Okay. I'm just kind of eyeballing these. They don't need to be perfect, but then we can actually probably. Oh, stupid! Don't do that. Something like this here. And we're just kind of eyeballing these up a little bit. So there's gonna be 6 LEDs that'll shine upwards. Let's see if I can take this and try to remember how to. Should be able to break a line. I'm trying to remember how to do that. Tools. Place. Is it over here? Let's see here. I know there's a way to break a line. I'm trying to remember how to do that though. I've done it forever. Inspect. Place. Let's see here. Alright, let's go to Google. How to break a line in KiCad. Let's see here. It's not being too obvious. There is a way to do that, and I'm trying to remember how to do it. For now, we'll just do this. Let's see something like. It's not gonna like that when I. Actually, we might need to. Okay. We'll redo the circle here in a second, but for now, I'm just going to kind of eyeball some of this. It'll make a bit more sense once we in here. Try and get this lined up right. Willing to bet that's not gonna work like this. Yeah, okay. That's what I thought. So we can do an arc, which is gonna be a bit tricky, but a good way to find the center of this, is there? It's close. Okay. And then up here. That's pretty close. Good enough for me, I think. Let's bring that down. Are those connected? It's not. Okay. Let's see if that actually. Nope, that still doesn't like that. All it takes is one deformed edge, and it won't like it. Let's run DRC, which is for some reason it doesn't like this one. Those look fine. View. No, come on. Why? Oh, maybe that's it. View. There we go. Okay, that looks hideous. I'm just kind of getting a rough idea here. Now this, I'm going to stick here, put it on the bottom, which will make a bit more sense in a little bit. Okay. So we've got those. We've got our buttons here. Turn off most of this stuff. Same thing over here. Another thing I need to figure out is how big of a battery can I fit in this thing. Do with my, here's one. So this is basically 50 millimeters by 35, 50 millimeters. So let's go. Yeah, I could probably fit one in here. Oops. 35 is kind of be a bit tight, but okay. Let's draw, just for the sake of it, let's draw a, so I'm going to go 50 by 35. Thereabout, doesn't it be perfect, just so we get a rough idea here. This is just so that I can have like a visual representation of, where a battery might go, or the battery that I have that I could fit in here. And then I can design around it. We'll move this down a little bit. The actual battery connector might be a little bit tight in here. We actually might be, whoops, not E. Might be able to just something like that, maybe. Not exactly pretty, but okay. Then we got a reset button. We can put these down here. And let's actually, I want to see roughly how far this sticks out the, so that's 8.6. Okay, that's fine. Okay, let's find our other, where's our other switch at? Where'd the other one go? There it is. Okay. All right, let's take a real quick look at this. Again, nothing to write home about. Need to figure out where we're gonna put all this stuff. Leave that alone, I guess. All right, so let's find all of our caps. Turn all these off. Oop, oop. This one. Oops. It's off. Okay. Oops. Come on, you stupid thing. Try to move them all, not just one of them. That's the other thing I need to change. I was going to have that up here, but I don't. This thing actually needs to go between VBAT. Move this. Sure, sorry, I don't know if you can see what I'm doing. I'm readjusting where this physical switch is going to be. Actually want that to be between VBAT. So the biggest challenge for this really is honestly, how do you tell it to turn on? Oh, excuse me. Would you put a glass on it? And, you know, basically the weight of this is probably the easiest thing. And at least for this revision, what I'm planning on doing is just using a, let me go to the other camera real quick. Using a little limit switch like this. And get focus. And literally have it on the bottom of the PCB. And then hopefully the weight of the 3D printed housing and the PCB itself won't be enough to actuate that. But if you have it and then have it sitting like this, and then you put your drink on it, then it would turn on, and then this would make the connection for the battery, which would then turn on the whole system. That's the idea, at least. Go back to desktop. So, let's go back. I'm trying to find my... Okay. So we've got that. Need to kind of lay out some of this stuff, though. Turn all these off. We're going to have 2 LDOs because I'm going to have some RGB LEDs on here, and I don't want to try and run them all off of one LDO. Might be able to get away with it, but might as well just add a second one. And we'll go figure out where to put this stuff. So let's... I like to keep most of it away from where the battery is, so I'm not setting a battery on top of anything. We're also going to have battery voltage monitoring, and we can monitor when the USB is plugged in. So I can actually have it, you know, glow green or whatever while I'm charging the battery in it. So let's figure out where the rest of the stuff is. So we got, oops. That's one, and the other one. Okay, goes up here. Oops, that's not what I wanted to do. Turned that off on the wrong page. Okay. One. I turned off the reference designators because I don't like the way they look on the PCB. She goes over here. Okay. This one's gonna go down here where the button's at. And this is the same way. Just kind of getting these kind of roughly laid out where they need to be down here. The other thing is, got these two. once we get these kind of laid out, especially since this is a fairly wide open design, shouldn't take too long to lay it all out, or run the traces rather. Dang it. Okay. Put this one down here. Okay. Have I tried wireless charging? I have not. Something to think about though, for sure. Um, I mean, in a sense, this thing's gonna kind of look like, you know, one of those wireless, you know, Q chargers, whatever they are. But I haven't actually made anything with wireless charging yet. Where was I? Let's see here. Okay, so this, let's do one of these. That one. Okay. Okay. And what's this one's? Tiny, but it's fine. Literally just kind of getting these moved around where we need to go roughly. So it's gonna go to a lipo charger. The second LDO. Okay. Let's see here. We got this, which will come up that guy. And then our charging LED. Don't necessarily need, but okay. So let's add, oops, not that one. Add a ground layers to the top and bottom. Close that one. All right. It just puts like a thin layer of copper on the top and bottom, which I connect to ground. Makes routing some of the ground stuff much easier. Let's see here. So the first one we need to go through is reset. Wonder if, I'm trying to think here. Let's rotate it. Not too much. Go 15. Gonna make it look a little better, I guess. Okay. Actually, move this up a little bit. That. Okay. That is, okay, so these need to be flipped. Maybe even Something like this. It's gonna go. Yeah. Do something like that. Okay. Connect these real quick. Okay. VBAT's gonna come down there. Take that one around. Okay. Yeah, okay, this is the first one. Let's figure out how we want to get this laid out here real quick. Let's see for the second one. I got these backwards. Let's go. Doesn't really matter. Plenty of room here. Okay, so this one's EN. LiPo charger. Let's see. Oh, those are gonna go. Okay. Make sure we get rid of that. I don't need that one. Let's update. Okay. This down here. That's what I need to fix. I need to come up a little bit. Let's add a label. No, not that. Date. Okay. It should. Edit this real quick. This symbol. Input. Okay. Save that. And date. There we go. Okay. We got that one. Switch. Trying to get all this stuff kind of laid out where it needs to go. It's a lot of looking at the schematic and I'm looking at the print here. Okay, that's coming from there. Can actually maybe even swap these around like that. Let's connect a few of these. And let's rotate that. Okay. I wonder if those should be backwards. Might make it a little easier if that. This here. Come on. Okay. We'll connect these two. Like so. Our Ian pin. Okay. Then our V bus can come way down here. Oh, oh, oh. Okay, connect those. Like that. And connect our grounds real quick. And those up. Like so. And let's see here. Silly, but that's how we gotta do it. Okay. Something like that. Okay. Reset. We gotta. That's way up here. Actually, let's probably just do this. Go underneath. Okay. Let's do this. Okay. And then boot's gonna be kind of the same deal. Let's do that. In fact, this one might be able to. Yeah, let's do that. These we might be able to move over here. Maybe. Let's see here. What's that going up here? What's. Oh, right. Okay. These are my voltage divider, which connects here. So do something like that. And I guess we can even kind of move this down. It doesn't have to be completely symmetrical. Something like that, maybe. And let's take this up here. I'm going to try and keep this as a 2-layer board best I can. Okay. Of course. That one. Okay. And we got our USB sense here. Connects to two. Move these down, move that up. Tiny bit here. Okay. Goes way down there. All right. It's getting a little tricky, I guess, but let's see here. So let's these. Yeah, those are two different ones. We do something like that. Okay, there we go. Connect those. And oops. Come on. Let's be nice here. That. And then like that. Okay. Those are connected. And easy, I can get a it's not too bad, I guess. That's the thing. Do I want those over there, or will it make more sense to have these over here? Something like that. Okay. There's that 3-volt going way down there. All right. Fair enough. Okay. We gotta run these up here now. That. And this one's gonna go here. Kind of got these going everywhere. These two are gonna be fun to get our in fact, let's kind of get a little creative here. I had a if this is a 4-layer board, it'd be a lot easier to get some of this stuff laid out, but I want to avoid making this a 4-layer if I can. Just try and keep some of the cost down, because this is not a real product, it's just for fun. And seeing if this stuff works. Let's take this one up here. Okay. this guy. I can get him around. There we go. Okay, got him run up to there. Those are not connected. E-bus. Guess we could probably just do like a strapping pin. Do something like that. Okay. And then the 3-volt. Okay. So 3 volts is gonna go over here somewhere. Or actually, those should be backwards. Oops. Get these straightened out a little bit better. Like that. Okay. Make it a little bit easier on ourselves. Okay. And then I need to putting Vias everywhere. Try and get this to line up better. That one's gonna be fun. Okay. Oh, right. I've got our charging circuitry. Let's see here. This one, we'll probably put this over here by our, closer to our battery. Wait, how much are these? That one's that one. That one's that one. That one's that one. What's this? Ah. Okay. Let's move these over here. So VBAT, VBus. All right, we might even be able to put it like, I don't know, down here maybe or something. That's VBAT, VBus is there. Trying to find the best place for this. We're getting kind of close here though. We got this. Charge LED, which we will put down here. Put this one underneath the battery. I don't care about that so much. Okay. Then this one. Bring this down here. Okay. And we can put it here, I guess. Do something like this. Okay. Connect those. Oops. Connect that. like that. Although getting those. If I can get this through there. There we go. Okay. Ground's not connected, and then that one is these two. Whoops. Don't need those. Okay. Let's probably put this down a little bit so it's not quite as close to the battery. Okay. Okay. Let's see here. Those are connected. And then this one is five and two. Yeah, those are both ground. Okay. Actually, maybe. Oh, not that one. Hopefully those are connected. I would assume they are. Okay. So that's hooked up. Now we just need to RV bus through here somehow. Along a curve is kind of ideal there. Okay. That looks terrible. But if it works, it works. Okay, so then we got our 3 volts. Oh, that's gonna need one down here. That. Okay. And it looks like, oh yeah, that V bus. Where does that go? That could be interesting. How am I gonna get that over there? We need to move these over here. So I don't see how I'm gonna get those. Like that. Okay. And on. Then this is probably not the most efficiently traced board, but like I said, this is just for fun. I am not too concerned about it, but here, let's go Okay. Those are all. Okay. B is here. For heat dissipation. Oh. I mean, it doesn't really matter. I'm just kind of making these look a little prettier, I guess. Okay. Something like that. All right. So, kind of the last thing we need to do here is if I can. Is trace our RGB LEDs. Actually, let's take a quick look at this and just see what it looks like. I don't have the model loaded for half the stuff, but this big open area is where the battery will go. I'll put in some mounting holes as well. Okay. Back to my. If I can find the. Or if it's worth trying to find. Be sought. SMD. I think it is that one. Yes. Turn on some of these 3D models. Be the same way. If I have the 3D models for this one or not. Parts. Let's see here. Looking for a step file. I know I have some of these somewhere, but 3D model, oops. Is it? So, no, that's not the right one. Yeah, not that worried about it. Okay. So I've got that. All right, so now we need to actually run. In fact, getting that over there is going to be kind of a little bit tricky. Let's see here. So we need to get this over there somehow. So a lot of like up and over here. Actually, let's do it this way. Let's go here. There we go. Not as bad. Not as bad. Okay. And then we got to get that over there as well. Let's see here. Oh, oh. Okay. Then that goes underneath. Oh, something like that. Getting that one down there is gonna be fun. Like that. Basically, we have to connect these in sequence. Go underneath again. Something like might not be in order. It should be. That's not connected. Oh, that's what I did wrong. Okay. The wrong pad there. So it should be from here. There's a lot of hopping around going here, but it is what it is. And then okay. Come on. All right. Go. Then from here. Again, this is not the most efficient layout I've ever done, but this is just for fun, so okay. Got those. Those are connected, so now we need to connect, make sure all the 3.2s are connected. And let's do something like here. Okay. And then same thing here. Let's move this or get rid of it for now. Okay. And okay. Here. All right. So got a bunch of ground layers that weren't connected here. Right. Yeah, something like that. And then this one can come up here. There's like traces going everywhere. It's kind of ridiculous, but again, whatever. Those are technically connected. Or at least they should be. I don't know why that's. Those grounds are not. Okay. Oh, I didn't connect them down here, did I? I don't think I did. Okay. Now they're technically connected. All right. Let's run our DRC. Oh, not that. Let's run our DRC here. Things that are not connected are what? Okay, we got some that are connected here. So we're gonna need some strapping pins. Oops. Oops. Okay. Those grounds are not connected, which should be fairly straightforward here. In fact, I can even make close. Connect them that way. This again. Those grounds are not connected. Which, let's see here. Slowly going through here, making sure they're all connected. Here. There. Okay. And those two are not connected. Which that one's gonna be a little more fun. Maybe, I don't know if I can get away with just. Yeah, okay, I did it. Don't care about those. The clearance violations, don't care about those. Those. Don't care about those. Okay. And let's delete these because I don't want that on there. Same thing with this one. Okay. Now we can add some. Actually, I might. Let's see here. That's kind of how it's looking right now. I don't think those are very symmetrical, but these buttons here. Something like that, maybe. Okay. Okay, let's silk screen. Let's type in reset 25. Come on, grab the stupid thing. Here again. Rename that. Save. Oh, that is not what I wanted. Looks pretty bad. I need to add some mounting holes to this actually. Let's do that real quick. Here. Mounting hole. Yeah, let's do it with a pad. Turn this off. Ground to it, and let's do a footprint. Mounting hole. And let's do... I think it's 2.5, I think. I think it's 2.5. One second here, let's see. Got some screws I can mount it. I just want to measure the diameter on the screw itself so I can... No, that's... So when you go 3 mil. Good thing I checked. So let's go 3 millimeter. Top and bottom. Okay. All right, so we got those. This. Make a couple copies of it. Save. Update the schematic. Annotate. All right. These here are our RR. No, not that. Turn off the reference numbers because I don't want those. Okay. Now I'm going to find places to put these. Something like that. Spacing on these might not be amazing, but I don't want those all the way to the edge. Like that, maybe. They're not very symmetrical right now, but doesn't really matter where these go, just because I can, when I make a 3D printed case, I can put these wherever. That looks so bad. Oh my goodness. Look at that. Oh, that's something else. So, what we've got here is place for an ESP32. We've got 6 RGB LEDs on here. Mounting holes. Got a place for a battery, a specific size battery that I measured out. Got our connector. In fact, like I could even maybe, I mean, I could just solder the actual, that's not a bad idea. I'll leave that there just because I can put a connector on, but I could just solder the battery to the board. That way I can kind of tidy up the, tidy it up a bit. We got our USB, which is going to be down here. I've stuck it out on this little peninsula so that when I make a 3D printed case, I can stick that nub or tab kind of through the 3D case a little bit so the USB connector is actually accessible from the outside. Hopefully that makes sense. But yeah, as you know, throwing this together in an hour is not, it's not the end of the world. It'd probably work. It's not pretty, but yeah, we got some mounting holes. We have a spot for the limit switch, which is here. If you guys happen to just join, basically I'm making a, this is just for fun. It's a smart coaster, as you want to call it, for your drinks. Basically, if you ever seen like Drink Masters or whatever, they have this, try to zoom in a little bit here. They have like this light underneath their, or built into their countertop, which I'm not building an entire countertop, but I think it'd be kind of cool to have like, you know, a light that you could light up your drink or whatever. So I'm gonna make one of those just for fun. Initially, I was gonna make a dumb one, but I thought I've got ESP32 modules laying all over the place. Might as well make it smart so that I can control the RGB LEDs and, you know, their brightness and the color and all that fun stuff. The limit switch, the idea behind that is that it's going to be mounted upside down on the, let me see if I can zoom in here, upside down. And it'll stick out of the 3D printed case just enough to where hopefully it doesn't trigger by the weight of the case itself, but as soon as you put a drink on there, it'll trigger. I could even take this arm off if I need to and just use the actual little nub. And that will turn on the power. That'll do two things. One is if the battery is constantly disconnected until that limit switch connects, then you're basically the ESP32 is just going to be off. It's not even going to be in deep sleep mode, which will save on battery even more. Basically, it'll be negligible, if anything at all. Whereas if you're putting it to sleep constantly, which you could do, it's still going to draw, you know, 20, 30 milliamps, or not milliamps, microamps of battery. But, you know, seeing as this is something, you know, you might use once in a blue moon for fun, I don't need a draining battery for no reason. So that's the idea behind that. We'll see if it works or not. If it doesn't, then I'll just like, you know, I'll just jump these and just use the deep sleep functionality. But that's kind of the idea behind it, at least. Yeah, so this is, I think that's everything. Got that, we got that. RGBs. We got two LDOs, or, you know, voltage regulators. So one can power the ESP32 and the other one can power the RGB LEDs. Might have been able to get away with one just fine, but I figured might as well just make it. That's the other thing I want to make sure. So the battery from the power from the battery comes into the switch. It gets turned on, which comes up here. It goes, okay, it goes into our MOSFET. which then feeds both of the voltage regulators. Okay. Yeah, just making sure I got that laid out right. Yeah, I think that's it. That comes up here. We can monitor when the USB is plugged in. So that's the thing, like, even, so if I plug in USB, the switch does not have to be activated for it to turn on. That's only for the battery power when it's powered off a battery. So I can plug it in to charge it up or program it or whatever, and I don't have to, make sure that switch is engaged the entire time. At least in theory, that's how that should work. So now I should put like a trying to think here. I wonder if I should. I'm also going to put in a couple of like just small, um, really small holes so that I can 3D print little tiny brackets that at least will hold the battery down in place. Because as it is, you just connect the battery and then it's just kind of dangling here. Or you could, I guess I could use tape too. I guess I could just use tape. Just put a little bit of double-sided tape to stick it on there so it isn't sliding around if you pick up the coaster or whatever. Yeah, I'll probably just do that. It seems easier. Because in theory, like, you wouldn't have to take this thing apart anymore. You would just, once it's assembled and if it works, then you just plug it in to charge it and call it a day. Okay. Let's, oh, no, I don't want to plot it yet. Nope, that is it. That is not right. Let's see if this will print. That's not the preview I want, but hopefully it prints it okay. Printing it off, we can actually see the physical size of it. Am I still on? Oh, I'm still on this one. I didn't realize I was still on my main cam. That's how big it'll be. So I'll 3D print a case to hold that. And then, while it's inside of your case, put your drink over the top of it, and it'll light up your drink, in theory. You could also do, like, since it has an ESP32 in it, we could do something stupid, like track how many times you lift your drink up, if you really wanted to go that far with it. But, like I said, this is just kind of for fun right now. Back here. Apologize that if it wasn't on my desktop, I don't know how long I was off the wrong one there. Let's see. We can get rid of this. I don't need that anymore. We should name this. What should I name this thing? Really dumb smart coaster. How about that? Okay. That's the official working title. Again, I mean, this thing looks terrible, but just as a proof of concept for fun, you know, I could spend 2 or 3 hours cleaning it all up and making it look pretty, but I just want to see if this will work as is. So, got that. Let's go and plot it. Let's see here. Got a new folder. Done. Smart coaster. Select. Okay. Make sure we got everything we need here. Oh, that's the other thing I need to do. Let me make sure that this is. Hit it. Paste. I need to actually update the full one, so I don't have to do this every time, but this tells them when they make the stencil to cut these out so that when I put paste on it, it'll actually put paste where the mounting holes are for the USB-C. Okay. All right, now let's plot it. Nope. Plot to our drill files. Okay. Let's open up our Gerber viewer so we can take a look at these. Our job file. GLC PCB. That. And let's open up our drill files. Okay. Turn them all off. These are the different layers that you send to JLC PCB or PCB or Way or whoever else you have make your boards. I go through and turn all these layers on one by one and just make sure, you know, things aren't overlapping or, you know. No, that's a copper layer. That's the front copper layer. That's a paste layer. So this is what's going to, in fact, we can turn this is basically what they will use to cut out the holes on your stencil. So we can make sure that, you know, it looks like all of the pads and everything look correct. This is our solder mask layer. So it looks fine. Our silk screen, which basically looks fine. Okay. All right, looks fine. So let's take, let me open that back up again real quick. So you just take all of these files. We're gonna zip them up. Okay. And then let me see if I go to JLC PCB real quick. Sign in. Second here, guys. Okay. So go here, go to order now. And we're just gonna drag that zip file in here. Give it a second. There she is. Okay, it's $2. That's not bad for 5 of them. And I'm just gonna leave the thickness the same. Let's see. Ideally, you'd like white, but that's gonna be too expensive. No, Okay, cool. Reason I want to have it white is because like if it's inside of a coaster that's making light, white bounces light more, so we will stick with white. Since I'm just making these for myself, I'll just leave it. I'm just gonna leave all the other basically defaults the same. Normally I would do eneg for stuff that I sell because it doesn't have lead in it. But if it's just for me, so I don't care. They've actually added some new stuff. Like copper core didn't used to be here before. It's interesting. I don't know what that is, but yeah, okay. Let's turn on. We'll get a stencil. So it was 75, 80 millimeters to a custom size. Let's just do like 125 by 125. Always do a custom size on this if you're just getting like a single little board, because like their default size is like 380 by 280, which is a big sheet. I've made that mistake before. So, okay, so for $9, we can have this little dumb smart coaster PCB made. So I will save that to my cart. I will order that later, but and then when those show up, design that or build it on stream. Usually it's also a good idea, like if you are designing something for real, for like, not something stupid like this. It's a good idea to, like, before you actually purchase it, wait 24 hours or come back the next morning, look over your design again. You'll be surprised how often you'll find little mistakes. You're like, oh yeah, I should have fixed that, or because the worst thing that happens is you pay and you have them start making it, and then while they're making it, then you realize you've made a design error, and they're gonna make it and send it to you, and it's not gonna work. So I've been there before. I didn't label this, but I know what that is. So basically, this will let me cut the status LED of the charge controller, because by default, if you don't have a battery plugged in and you plug in the USB, it will blink. In fact, I can show you exactly what I'm talking about. On my PS3, it's blinking right now because it can't find. It's like, hey, I'm trying to charge a LiPo battery and there's nothing here. You can use that. You could cut it so that it doesn't blink anymore. But what it won't do is if you plug in a battery and you've cut that, then it won't give you a status of if it's charged or not. So it's just a little thing. But in a smart coaster where like you're messing with light, it might be a little annoying if that little light's blinking occasionally. But so that's that. Let's go back here. So yeah, anyways, I don't know. Just thought I'd do this for fun today. That's basically the gist of it. Might be a little interesting for some people if you have, you're trying to design your own product or whatever. Maybe this video or live stream will be helpful for you a little bit. When it comes back in, I'll assemble it, assuming it works, because you never know. It could have gotten something wrong on here. And in fact, I'll probably wait till tomorrow to order it, and then I'll look it over and, look over design again, just make sure I didn't screw something up. But assuming it does work, then I'll probably build some CircuitPython firmware for it. That seems like the easiest thing to do. Or maybe, I don't know. Or I could make an Arduino library for it too. And just use Arduino. Because once it's programmed, like basically it should just work. I mean, it's not, there's no pin headers on this thing. I'm not using it to program it to do something else. It's literally got one purpose. and that's to light up when I put a drink on it, basically. You know, they make like, you can buy them off of Amazon for like, they're dirt cheap, but they're kind of disposable where like they have, you turn them on and it's like a little coaster and it has a sticky thing you can stick to the bottom of your drink. That's not what I want to do with this, but um, there's products out there. But again, I wanted to just kind of do this myself and have some fun with it. So yeah, I think that's basically going to be the stream for today. Not really much else to go over about this, but so thank you for tuning in and watching this. If you're watching this now or after the fact, appreciate it. And probably a couple weeks before this thing shows up. And then we'll assemble it and see what happens. So a lot of fun. So thank you for watching, guys, and I will see you in the next video. Later.